Hello, welcome back to my channel. In this video we'll be looking at the remainder theorem. Okay, remember in the former video we looked at division of polynomials and the division algorithm. So if you are new to this channel, please click the subscription button below so you receive a notification, and put on the alarm so you receive a notification whenever we post a new video. Okay, so this is the fifth in the series of our lessons on polynomial. So let's go. At the end of this lesson, you should be able to state the remainder theorem, and you should be able to use the division calculate the remainder of a polynomial without using the long division. Okay, so that's what we are looking at now. The division algorithm helps us to find not only the quotient of a polynomial but also the remainder. Okay, remember when we divide, the division algorithm, if the quotient the divisor is not the factor of the polynomial, you will always have the remainder at the end of your division. And normally you write your polynomial in this form. So you write your polynomial in this form. You have p of x equal to d of x, which is the divisor, multiplied by q of x, which is the quotient, plus the remainder. Okay. Now consider this polynomial: 4x cubed minus 7x squared plus 2x minus 3 divided by x squared plus 2x minus 1. Okay, let's see if you will have a remainder here. So write out the divisor, minus 1. I'll put the dividend aside. 7x squared plus 2x minus 3. Okay, let's draw this to cover. So the term we are going to use to divide here is x squared. So x squared in 4x cubed, we have 4x multiplied by 4x cubed. 2x times 4x, we have plus 8x squared, and minus 1 times 4 there, 8x squared, and minus 4x. So we will subtract all of this from here. We will have this, we cancel this. Minus 7 minus 8 will give us minus 15x squared, and the minus times minus is plus. 4 plus 6, 5. 4 plus 2, we have 6x. So we can still divide here. We can bring down minus 3. X squared in minus 15x, that will give us minus 15. Okay, so multiply, we have minus 15x squared. 2x times minus 15, we have minus 30x, and the minus 1 times minus 15, we have plus 15. And then if you subtract this, we're going to have minus times minus plus. 15 and 15x squared will cancel. 9 times minus is plus. 30 plus 6, so we have 36x. Next times plus is minus. Minus 3 minus 15, that will give us minus 18. Okay, so look at this product. So if you express this in form of px equals to dx times qs plus rx, you have 4x cubed x cubed minus 7x squared plus 2x minus 3. Okay, and the divisor is x squared plus 2x minus 1, while the quotient is 4x minus 15, and the remainder is 36x. Okay, 36x minus 18. So the remainder, r of x here, is 36x minus 18. Okay, so this remember, the remainder is having x because of the nature of the divisor, x squared plus 2x minus 1. Okay, so what we are trying to draw out here is the statement of the remainder theorem. This is a theorem. This is the theorem we call the remainder theorem. So the remainder theorem states that if the polynomial p of x is divided by x minus a until a constant remainder is obtained, then the remainder is p of a. Okay, so what we are saying here is that, let's write the proof. So what we are saying here is that if you divide p of x by x minus a, what you will have is q of x plus p of a. Okay, so your r of x here equal to p of a. That's what we are saying. So remember from the division algorithm that p of x equal to d of x multiplied by q of x plus r of x. Okay, so now if you are dividing by x minus a, you see, let's x minus a equal to 0, then x equal to a. So find p of a. So before you find p of a, substitute x minus a, because the divisor of d of x is x minus a. So if you substitute that here, you have p of x, okay, equal to x minus a. Yeah, that's what we are saying. So equal to x minus a multiplied by q of x. Okay, yeah, so which is plus r of x. So if you multiply this, know that x equals to a here. So if you substitute that, you have f, let's say this is p of a. So we have a minus a multiplied by q of x plus r of x here. So a minus a is 0, 0 multiplied by q of x plus r of x, and then we have r of x. So p of a, therefore p of a equal to r of x. Okay, and that proves the theorem. So also, if your divisor equals to ax minus b, okay, now you say ax minus b equals to 0, find x. So x equals to b over a, and then if you substitute in the division algorithm, d of x, q of x plus r of x, you have p of b over a equal to ax minus b, okay, because dx is ax minus b into q of x plus r of x. Okay, and then substitute x, which is b over a, you have a into b over a minus b into q of x plus r of x. So this is a will cancel a here, and then we have b minus b into q of x plus r of x. Okay, b minus b is 0, 0 times q of x plus r of x, and then this is 0 plus r of x, which is r of x. Okay, so therefore, if you divide a polynomial p of x by ax minus b, the remainder r of x equals to p of b over a. Okay, and that is the remainder theorem. So the remainder theorem helps us to find the remainder of a polynomial without using the division algorithm. Okay, so let us see a couple of examples. Use the remainder theorem to find the remainder when the first polynomial is divided by the second polynomial. Start with a. The first polynomial is divided by the second polynomial. So p of x here equals to 2x plus 7, and d of x equals to x plus 1. Okay, so we are going to be finding, so we let x plus 1 equals to 0, then we find x, so x equals to minus 1. So the remainder will be p of minus 1, which is 2 times minus 1 plus 7, which is minus 2 plus 7, which is 5. So r of x equals to p of minus 1, which is 5. Okay, and let's solve the problem. We do the same thing for the second one. For b, we have 3x squared plus 12x minus 28 as p of x and d of x equals to x minus 1. So if x minus 1 equals to 0, we have x equals to 1. So the remainder will be p of 1. So p of 1 equals to 3 plus 12 minus 28, which is 3 plus 12 is 15. 15 minus 28, we have 13. Okay, so r of x equals to p of 1, which is 13. Okay. Let's take one more of the example. 5x squared minus 11x 5x squared minus 11x minus 31. So here we have 5x squared for c. P of x is 5x squared minus 11x plus 31 minus 31 minus 31, and the divisor is x minus 1. So let x minus 1 equals to 0, and you have x equals to 1. So the remainder is p of 1, which is 5 into 1 squared minus 11 times 1 minus 31, which is 5 minus 11 minus 31. And this is simply 5 minus 42, which is minus 37. Think. So the last one though, we have x cubed minus 4x squared plus 3x plus 1. We have p of x equals to x cubed minus 3x squared. Okay. Send that is to extreme. Let's take it down a little bit. P of x equals to x cubed minus 3x squared. Right. That's 3x x cubed minus 4x squared plus 3x plus 1. X cubed minus 4x squared plus 3x plus 1, and the divisor is x plus 1. Okay, so now let x plus 1 equals to 0, then you have x equals to minus 1. So the remainder will be p of minus 1. Let's find p of minus 1. That will be minus 1 raised to the power 3 minus 4 into minus 1 square plus 3 into minus 1 minus 1, which is minus 1 or minus 4 minus 3 minus 1, and that will give us minus 1 minus 4. Remember, minus 1 square is 1. Minus 4 times plus 1, we have minus 4, and then we have all that. So this is all minus 5. Minus 5 plus minus 3, we have minus 8, and then minus 9. So the remainder is minus 9. So this is how to use the remainder theorem to find the remainder without using division algorithm. Now look at another example. When p of x equals to ax squared minus 8x plus 3 is divided by x minus 7, the remainder is 45. Find a. So now let's state what we have first. Solution: p of x is ax squared minus 8x plus 3. The divisor is x minus 7, and then let x minus 7 equals to 0, so that will give us x equal to 7. So let's find p of 7. P of 7 will be a into 7 squared minus 8 times 7 plus 3, and that will give us 49a minus 8 times 7, which is 56 plus 3, and then that is 49a minus 53. Okay, and remember that p of 7 is also given as 45. So we are going to solve the equation with, let's call this equation 1, equation 2. So if we equate equation 1 and 2, we have 49a minus 53 equal to 45. Okay, so 49a, subtract, adding 53 to both sides, we have 45 plus 53, and then if we add that, we have 8, 4 plus 5, we have 9. So 49a equal to that. So if we divide both sides by 49, we're going to have 49 goes here, we have 8 goes to, this is 49 here should be 2, right here, 2. So 2. Okay, so therefore a equal to 2. Okay, so this is applying the remainder theorem, or we can call it algebra of remainder theorem. Another example, when f of x equal to x cubed plus 5x squared plus kx plus 1 is divided by x plus 5, the remainder is 31. Find k. Okay, this is a like example. You can pause this video, solve this question, and check out the answer. So guys, we have f of x equals to x cubed plus 5x squared plus kx plus 1. Okay, and the divisor here is x plus 5. Okay, now let x plus 5 equal to 0. So that will give us x equal to minus 5. Okay, so now f of minus 5, which is the remainder, will be minus 5 raised to power 3 plus 5 into minus 5 raised to power 2 plus k into minus 5 plus 1. And that will give us minus 125 plus 125 minus 5k, because plus times minus is minus 5k plus 1, and that will give us this one. We cancel this one, so we have 5 minus 5k plus 1. Let's call this equation 1. Also, f of minus 5 is given from the equation to be 31. Now let's call this equation 2. So if we equate 1 and 2 together, equate 1 and 2, we're going to have minus 5k plus 1 to be equal to 31. Okay, and then if we subtract 1 from both sides, we would have minus 5k equals to 30, and then we can divide both sides by minus 5. So that will give us k equals to minus 6. Okay, so therefore k equal to minus 6. So another example, find the remainder when p of x is divided by g of x. We're looking for the remainder when p of x is divided by g of x. Okay, all using remainder theorem. You don't need to use the division algorithm again here. If you know the remainder theorem, it's a short form of finding the remainder without going through the long division step. So here for a, we have a p of x equals to x cubed plus 5x squared plus 3x minus 6. Okay, and g of x is our divisor. The divisor is g of x, which is x plus 2. Now you let x plus 2 equals to 0. So let x plus 2 equals to 0, so that you have x equals to 2 minus 2 rather. So your remainder is going to be p of minus 2. So let's find p of minus 2, which is minus 2 raised to power 3 plus 5 into minus 2 raised to power 2 plus 3 into minus 2 minus 6, and that is minus 8 plus 5 times 4, which is 5 times 4 is 20 minus 6 minus 6. Okay, so this is 20 minus 20, which is 0. So p of minus 2 equals to 0. So here there's no remainder, so you don't imply that. It implies here that g of x is a factor of p of x. Okay, that is what it means. The remainder is 0. Okay, and this is factor theorem. Okay, we're going to be studying a lot of this when we get in our next video, which we titled of factor theorem. The second example, p of x is x cubed minus 2x squared minus 5x plus 6. P of x equal to, so for b, we have p of x equals to x cubed, copy it correctly, x cubed minus 2x squared minus 5x plus 6 minus 2x squared minus 5x plus 6, and g of x, which is the divisor, is x minus 3. Okay, now let x minus 3 equals to 0, so that will give us x equals to 3. So our remainder will be p of 3. So p of 3, substitute 3 for x in the p of x. You have 3 raised to power 3 minus 2 raised to power minus 2 times 3 raised to power 2 minus 5 times 3 plus 6, okay, which is 27 minus 2 times 9, 18 minus 5 times 3, which is 15 plus 6. Okay, so this 27 minus 18 give us 9 minus 15 plus 6. 9 minus 15 will give us minus 6 plus 6, which is 0 as well. So it implies that g of x is a factor of p of x as well. Okay, so this is the remainder theorem and how to apply it, guys. Very simple and straightforward. See you in the next video, which is titled factor theorem. Bye bye.